Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
For this question, we're going to be considering a bone. We're told that the bone decreases by an amount when compressed, so I call this delta LC for the change in the amount when compressed of 2.7 times 10 to the minus 5 meters. It wants to know when the bone is subject to a tensile force of the same magnitude, how much does it stretch? So the force for compression is equal to the force for the tensile force for stretching. And the y sub c is the value of Young's modulus for compression, and that is equal to 9.4 times 10 to the minus, or times 10 to the 9 Newton per meter squared. And y sub t is Young's modulus for the tension of a bone, and it's 1.6 times 10 to the 10 newtons per meter squared. So we're going to also need those constants to solve for this. So to find this, we're going to take the ratio of the force from compression divided by the force from the tensile strength, or the tension, F sub t. So F sub c is equal to Young's modulus, y sub c, times the ratio of delta L, c, the compression length, divided by the unstretched length of the bone, L naught, multiplied by the area of the bone, A. F sub t is equal to y sub t, Young's modulus for the tension strength of a bone, times the amount the bone is stretched, delta LT, divided by the unstretched length of the bone, L naught, multiplied by the area of the bone, A. Well, F sub c is equal to F sub t in our situation, so those are going to cancel. So the left side of the equation is just equal to 1. The bone is the same. It has the same unstretched length, so L naught is the same for both. Again, same bone, so the area is the same for both. So what we have here is y sub c times delta LC is equal to y sub t times delta LT, where delta LT, the stretch of the bone from the tensile strength, is what we're wanting to find. And that's the only thing we don't know in this situation, so we simply solve for it, and we find that delta LT is equal to y sub c over y sub t multiplied by delta LC. Plugging those values into this expression, we find that this is equal to 1.6 times 10 to the minus 5 and the units here would be meters. We can box this in as the solution to our question.